in our previous chapters, we talked about elements. We've talked about how elements interact with each other to make compounds. And now we're going to talk about how compounds interact with each other to do chemical reactions. And so I briefly talked about these terms yesterday. But in a chemical equation, we have what are called the reactants that turn into products. And so I just put like a generic little equation below this saying reactants go to products. So remember that arrow, this just represents the term yields or makes, forms. You don't have to write all these down. I'm just giving you hints for when we get into the actual equations. But pretty much if you were reading a sentence and it says this plus this makes this, it's the same thing as if we put an arrow there. And so reactants are the compounds that we start with. And then I know it's been a while. Miss Murphy made a typo, guys. I'm off my game. So the second reactants there, this should be products. And so products are the compounds that are formed. And so when we're looking at these equations or these reactions, we also have to consider the energy that is changing. So the energy that is used to produce or that is produced in a chemical reaction. So we give them these special terms, the first of which being endothermic. This is when we are adding energy. So if you're putting energy into the system, we are going to describe where this goes in our reaction equation by writing the word energy. And so if you think we need to add energy or to happen, do you think it'll go with a reactant or a product if we have to add it for the reaction to happen? It's not going to be on the reactant side. So this is the left side of the arrow. So pretty much it's going to be your reactants you start with, you add energy into the system for it to happen. Now the other way, if it's exothermic, this means you're producing energy. So for example, if you start a fire, it gets hot, right? That heat is considered the energy that's being produced. So burning wood is actually an exothermic reaction. And so we're going to put the energy term on the right side of the arrow. Any questions about endothermic versus exothermic? Cool. Okay, so now we're gonna get into it then. We are gonna start writing chemical equations from sentences. And so the way that I go about this, I put some steps up here, but the biggest thing is identifying the compounds that we have to write formulas for. Then we have to think about what side of the arrow they go on. We're gonna indicate what state they are, so solid, liquid, gas. And then we're also gonna talk about if energy is involved, and we're gonna have to put that on one side of the arrow. So starting with the first one here, I'm going to read, and as I go, I'm going to underline my compounds. So we have a solution of lead 2 nitrate. So that's a compound I'm going to have to write a formula for. That is combined with a solution of potassium iodide to produce aqueous potassium nitrate. That's another compound. And the yellow precipitate lead 2 iodide. So in this equation, I have 4 compound formulas I'm going to have to write. Now, thinking about what side of the arrows they're going on, I have to look for my keywords. So a solution of lead 2 nitrate is combined. What symbol do you think will go in between lead 2 nitrate being combined with potassium iodide? A plus sign. Now, if it produces the last 2 compounds, what do you think we replace produce with? An arrow, exactly. So the last thing we have to think about then are the states of each. If you have a solution of something, what state do you think that is? A liquid, exactly. So we're going to use a parenthesis L. Again, we have a solution of potassium iodide. We're going to call that a liquid. And then we're producing something that's aqueous. So it's dissolved in water. But what is the symbol we use here? AQ. Now, does anyone remember what a precipitate is? It's a solid, exactly. A solid forms, if a solid forms when you mix two solutions together, it's called a precipitate. So this is going to give little s. Now, so we read through the sentence, we figured out all the parts. Now we're going to actually start creating the equation. So if I'm talking about lead 2 nitrate, what is lead 2? PB. That's okay. So that being said, you guys remember the sheet I gave you yesterday? It says don't throw away. You will have this. So if you ever forget lead, you can look back on this table. Anyway, so lead plus 2 nitrate. Now, if you were to go to the polyatomic table, you'd figure out that that is NO3 minus 1. Now, how would I write the chemical formula of lead nitrate? Yeah, go ahead. Exactly. So what I'm going to write as my final formula is PbNO3 2. And now I'm going to go back and give it its state of matter of L. We determined it's a liquid. So these states of matter also go as a subscript. All right, so we said the next part is combined. So this is my plus sign. Yeah. Yes, it's all lowercase. Good question. All right, and so now we're combining lead nitrate with potassium iodide. So if we break down potassium iodide, potassium, when it forms a compound, it goes +1. Iodide is a -1. So how do we write the formula for these ones? Exactly, we just need one of each because the charges are equivalent. And we're giving, again, we figured out it's a solution, so it's a liquid, so we do parentheses L. What comes next? Yes, the arrow. Because now we're producing aqueous potassium nitrate. So now we're looking at a potassium ion and a nitrate ion. How do those combine? Exactly, just need one of each. Their charges are equal. So how we'll write it is KNO3, and then we have to tell that it's aqueous. And then lastly, we are combining, because we're also producing that yellow precipitate, which is lead 2 iodide. So again, we have lead 2 and iodide, which is a -1. So what is the formula for lead 2 iodide? Wonderful, exactly. PbI2, and that is a solid. So this down here, this is my final answer. We just wrote our first chemical equation together. Congrats, guys, you're chemists. So what do you notice about this equation? I like to hear that. There are no superscripts. Are there any charges at all in this final formula? No. That's how it should be. We can do all that work figuring out each compound's formula so that there's no charges. Okay. All right. Any other questions before we move on to the second one? Okay. Now we're going to talk about aluminum foil. So aluminum, although it's an element, this is still something that we are going to write in our chemical equation. This is placed in a flask containing chlorine gas. So if it's placed in something that contains something already, then they're going to react together. So chlorine gas and aluminum are going to be reactants. Now, if we keep reading, it says white powdery aluminum chloride. Here's another compound we're going to have to write. Is produced and a large amount of energy is released. So when I see the word energy, I'm going to underline that because we also need to make sure that gets in our equation. So again, as we're reading, aluminum foil placed in a flask containing, that means it's going to be added to chlorine gas. And then it says that aluminum chloride is produced. So what side of the arrow does aluminum chloride go on? The right side, because it's produced, okay? What do you guys think about the term energy is released? It also goes on the right side because it is produced, it's released into the environment after this reaction takes place. So let's start writing the equation here. Aluminum foil, that's just aluminum. What do you think we write for aluminum then? Al. And what state is foil? It's a solid. And so one tip I'll give you guys is that if you have a metal, just a metal, iron, nickel, platinum, whatever, it's likely just going to be that solid metal. That's usually how we find metals. All right. All right. So this is combined with chlorine gas. How do you think we write that? Okay, I heard Cl with a G. Almost. So there's something missing about this. You guys remember the term diatomic? It's coming back.
Oh, I knew it.
So diatomic means that when it's all by its lonesome, element in its elemental state, if it's diatomic, it has to have two of them naturally. So what's missing here is the subscript 2. So you should have Cl2G. And so just a reminder, which ones are diatomic? There's 7 of them. Starting with number 7 on the periodic table, it forms the shape of a 7. Well, that's only 6 because hydrogen is hiding. Hydrogen is the 7th diatomic one, okay? So anytime you guys read hydrogen, oxygen, nitrogen, fluorine, you have to write the subscript 2. Oops, that was awful too. So why didn't I write it for aluminum? It's not diatomic, okay? Yeah. What comes next then in the equation? Arrow. We're done with our reactants. Now it told us that aluminum chloride is produced. So we have to figure out what the formula is for an aluminum ion, that's +3, chloride ion, which is -1. So what is it going to be? Awesome. And if it's white, a white powder, what state do you think? It's a solid. And we already said that we decided energy has to go on the right side because it's being released. So this is our final answer. What's up?
So like when energy is released, why are we adding it?
So we're not adding it to the system. If we add it to the system, it'd be on the left. What we're saying with the plus sign is that we have aluminum chloride and energy that was produced because of the reaction. That's what that plus energy means. It means that energy came out as a product.
Oh, okay.
Any other
So how
questions?
it released it, how, like,
I get what you're saying. Yeah, there's no minuses in chemical equations. Okay, we've got a few more to do. Okay, so number 3. When we start to dissect this one, it says a drop of water. Now, that compounds quiz that I'm going to start giving you guys, this is exactly why. You guys should know the formula for water off the top of your head. What is it? H2O. And so that's placed on a lump of sodium metal. So we have got sodium here. Energy is released. So again, what side are we putting energy? Okay, I'm going to write myself a note so I don't forget. And so if it was released and this is what's produced, so we're going to put our arrow, and then we're producing aqueous sodium hydroxide and hydrogen gas. So now we have to start writing our formulas. Well, we already talked about water. We know that's H2O. And if it's a drop of water, what likely is its state?
liquid?
Awesome. It's a liquid.
Wait,
Yeah.
What's aqueous again?
Dissolved in water. And so now this is placed. So if it's placed on something, it's going to be plus. So it's placed on a lump of sodium metal. How do you think we write sodium? Na. And what state? Solid. Now we're producing. And so since I don't want to forget energy, it doesn't matter where on either side. So let's say I determine energy has to go to the right of the arrow. Doesn't matter where. So I'm going to put energy down before I forget to do that. And then we also have to talk about the couple things produced being, yeah, go ahead.
Why has energy been released before it was produced?
It's just how the sentence was written.
Should it be before?
Shouldn't what be before? No, because energy is being released. So it's just learning the terminology and what it means. Don't get hooked on where these terms come in the sentence that's describing it.
Oh.
Just focus on the fact that if it's being released, it has to go on the right side. Yes. Because that's representing an endothermic versus an exothermic reaction.
What would be the other?
Like, what would be an example of how it'd be written?
Like, so this one's exothermic?
Yeah.
So what would be an endothermic? How do you know?
Because let's say I told you you added some stuff and then I said you continually heated it. Heat is energy. So if you continually add energy, that's endothermic. So then you'd put it on the left side.
So if it's continually happening, that is something.
If it says that you did that to the reactants. Okay. All right, so now we have sodium hydroxide. Sodium forms a +1. Hydroxide forms a -1. How do we combine these two? NaOH. And then what is our state here? AQ. And then our last product, what is it? Yeah, I'm hearing those H2s. Somebody was paying attention. All right, this is our equation here. So again, I'm just going to write myself a little note that this is a 2 because it's diatomic. Correct. It's hiding. Hydrogen is hiding. Yes, JP.
Just want to, what if it said dihydrogen?
So the reason it doesn't is because it's assumed you know this.
What if it's like trihydrogen?
Then you would write H3 if it literally says that. But it won't.
I thought like adds on since it's like diatomic,
Mm. No, that's fine. Any other questions before the next one? Okay. So now we're reading this one. When combined, so let's see how combined comes before we even talk about what's being combined. So we know we're adding the next couple things together. That's going to be nitrogen gas and hydrogen gas. Then it's telling us that it's producing ammonia gas. And I gave you guys the formula here. But again, ammonia gas is another thing that if I tell you ammonia, you should be able to tell me NH3. Like that's just common knowledge. So this again is relating back to the compounds quiz. But anyway, so the rest of this sentence is just fluff. It's not telling us any information. So we have all we need right here. How do we write nitrogen gas? Exactly, N2G. What about hydrogen gas? Wonderful, they're both diatomic. What comes next?
An arrow.
Arrow, and then we're producing NH3 gas. So this one wasn't too bad. We didn't even have to think about writing ionic formulas here. Any questions about that one? Oh wait, last one here. When carbon tetrahydride, so here's a compound, is ignited in the presence of oxygen gas. So in the presence, we're going to think of that as our plus, and then we have oxygen gas. It says a large amount of energy is released. So again, we're putting energy on the right side because it's released. And then it says which vaporizes the water and carbon dioxide products. So it's telling us that water and carbon dioxide are our products. So this one's worded different than ones we have in the past. So you really got to be careful of how you break these things down. So carbon tetrahydride, is that a covalent or ionic compound? It's a covalent compound. If you see a prefix like tetra, that screams covalent. What does tetra mean? 4. And then hydride is for hydrogen. So how would we write the formula for carbon tetrahydride?
C4.
Exactly, CH4. And it says that it's a gas, so I'm going to put a G after that. Then we're going to write plus because it's in the presence of oxygen gas. How do we write oxygen gas?
O2.
Exactly, O2 gas. So, good question. Guys, I want you to listen up here. Now, ignited. The question here is, does that count as energy? And I'm gonna tell you guys no, because of how quick and short lasting it is just to ignite something. It doesn't really take an input of energy, it just starts the reaction. And so really, if you see ignited or sparked, don't worry about it. What matters is if it tells you if energy is released or if something was continually heated. Great question. Any other questions before I continue? So this now produces water, which we know is H2O. And what's carbon dioxide's formula?
CO2.
Bam. What state are these in?
Aqueous. Aqueous.
Nope. What do you think vaporizes means? What's a vapor? It's a gas. So both of these, wrong color. Both of these are in a gaseous state. Bless you. And we have to add energy. And this is our final one here. It does not matter where on the right side, as long as it's on the right side of the arrow. Yeah.
No. We know what